In this video, we're going to talk about nullable arithmetic, whatever that is. We're going to talk about null propagation, which is one of the ways that nullable arithmetic does its job. We're going to talk about an odd little operator called the null coalescing operator. And we're going to talk about how C# handles member accesses on null and how that's changed in C# 6. So to start with a brief refresher, you know that there's a difference between value types and reference types, and that there's a null reference. The null reference can be used to represent an invalid value. Right? So you might say, well, what is the name of the present king of France? Well, France doesn't have a king. So you might think, well, maybe it's the empty string, right? But really, is the name of the present king of France, something that is 0 characters long? That kind of implies that there is a present king of France when we know that there isn't. So you can use the null value to say there's not even an empty string. There's nothing at all, right? This is the reference that refers to no thing whatsoever. Now, you can also use nulls to mean something unknown. So for example, suppose you were trying to do some business logic where you were trying to compute the sales for last December, but not all of the salespeople had reported their sales figures yet. Right? There is a actual sales figure for December. Right? You don't know what it is. So in that case, you might say, well, the sales are null, meaning there were sales, but I don't know what they are. So the clever viewer will have just realized that null can be used to mean two completely contradictory things. Either there is no thing at all, or there is something, but I don't know what it is. And so you got to be careful when using this thing to make sure that you understand what the right semantics of it are. So we would like to be able to represent in C# this idea of invalid or unknown integers, decimals, doubles, and so on. But those are all value types. And value types don't have a null reference because they're not reference types. So what do we do? Before I get into how that actually works, I want to give you a quick fun fact here. This is a picture of Sir Tony Hoare, who is a very famous computer science researcher. He works for Microsoft Research in England. I've met him. He's a super nice fellow. And he invented the null reference. And he famously said, "I called it my billion-dollar mistake. It was the invention of the null reference in 1965. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. I think that Sir Tony is vastly underestimating the cost of the billion-dollar mistake. And I think it's a many, many billion-dollar mistake. So the key takeaway here is be super, super careful with nulls, because it is very easy to get them wrong. So let's take a look at some code. All right, here we are in Visual Studio. And I have just whipped up a little console application here to illustrate some of the points about nullable arithmetic. So here's how it works. In C#, any value type, any perfectly normal value type, like integer or decimal or date, date time, or whatever, can be made into a nullable type by simply appending a question mark to the end of it here. So here we have a variable. The type is nullable int. The variable's name is x. And here we have a variable. The type is nullable double, and it's called y. There is an alternative syntax for this that hardly anybody uses because the normal syntax is so short and succinct. And that is to say nullable. This is pronounced nullable of decimal. We have the type name nullable, and then the type decimal inside angle brackets after it. And you can put any type in here. And here we are saying this is a nullable decimal. The variable's name is z, and here's its initial value. And you see we can just assign just a perfectly normal decimal literal to this thing. So the nullable decimal can take on any value that a decimal can take on, and it can also take on the value null. You'll notice that Visual Studio has slightly dimmed out nullable decimal here. And if we hover over it, you see we get this light bulb that says this represents a decimal number, and name can be simplified. And if I click on the light bulb, right, then it says, well, you could simplify this name, and it turns it into the shorter syntax. So anytime in Visual Studio you see something that is very slightly gray, it's telling you, well, this thing is right, but there might be a slightly better way to write it, and it will then automatically reformat the code for you if you choose. All right. Reference types are already nullable. Every reference type you can assign null to a variable of that type. So it is illegal to try to make a nullable reference type. You see we get a red squiggly here, and if we mouse over it, it says the type, string, must be a non-nullable value type in order to use it as parameter t in the generic type or method nullable of t. This is a very wordy error message. I wish that the C# team had simply made the error message say the type string must be a non-nullable value type, and left off all of this business about the fact that this really has an alternative syntax where it says nullable of t. All right. Now you'll notice there that the error said that the type that is being made nullable must be a non-nullable value type. So what happens if you try to make a nullable value type nullable? That is also an error. So we can't say int question question. But the error message is really weird. Here it says identifier expected, semicolon expected, invalid expression term, and then 2 question marks. The compiler is getting very confused here. It really should be giving you an error message that says that the nullable int type is already nullable and you can't make it nullable again. We will see why the compiler is getting so confused later on in this video. All right, so now that we understand the type syntax, let's talk about how nullable arithmetic is exactly like normal arithmetic. So we had a nullable integer, x. We had a nullable, what was it, double, y. We're going to assign 123 to the integer. We're going to assign 456.7 to the double. And then I'm going to say this nullable double, the sum, is equal to x plus y. And everything seems to just work. I'm going to put a breakpoint right here, and I'm just going to run this code. All right, and if we get here, then we can see, we can mouse over this thing, and it tells us that or we can look in the watch, in the locals window here. And we can see that the value of the sum is 579.7, which seems exactly what you would expect if you added this integer to that double. So what happens if there's a null value in the mix? Well, if we assign null to x, which we could not do if x were merely an integer, it has to be a nullable integer, then let's step over this thing. All right, we can see in the locals window that x is now null. And you see also that it's, recall that when something has just changed, it is highlighted in red in the locals window, which is a handy debugging aid. All right, so now what do you think s is going to be when we add null plus the value of y, which is still 456.7? Well, we can look at it here, and it turns out that it is null. So the operator, the addition operator in this case, is said to be lifted to nullable. And lifted operators perform perfectly normally when you give them all non-null operands. They produce null if you give them any null operand. Right? And the reason for this is because we're interpreting the nullable in this case as unknown, as I don't know. So we're saying I have something I don't know plus a particular value. The result is something I don't know. Right? Now, you could also think about this as I have something that is completely invalid. I've added something to it, and the result is also something that's completely invalid. Both of those interpretations are pretty reasonable interpretations. So essentially what happens with nulls in lifted operators is that the nulls propagate. Right? So if one input to a particular expression is null, then the output of that expression is likely to be null. If that expression is then used somewhere else, then that result is going to be null. And if that result is used somewhere else, then that result is going to be null, and so on. Right? So once you get one bit of unknown information into a system, it tends to spread through the system. and that's called null propagation. Now, there is one exception to this rule, and that is with nullable booleans. Booleans are value types. You can make them nullable, and then you might ask the question, suppose I have one Boolean variable, and it's a nullable Boolean variable, and it's null, and I have another nullable Boolean variable, and it's true. And I ask, are either of them true? Well, in that case, you would not want to say, well, no, the result of that is null, right? Because one of the operands is null. In that case, you would want to say, no, the result of that thing is true because one of them is true. So the Boolean operators do not exactly behave the same as all of the other lifted to nullable operators, but we're not going to talk about the fiddly little details of that in this course. Now, we know that using an instance method when the receiver is null, if the receiver is a null reference, causes an exception. We saw that in the previous course there was a null reference exception when that happened. However, instance members can often be used on null value types. If we look at hasValue, either with this data tip by mousing over it or looking at it in the locals window, we can see that it's false, right? The property did not throw a null reference exception. This thing isn't a reference. It's a null value, but it's not a reference. Now, what is going to happen if we try to call toString on that thing? OK, again, it did not throw an exception. And if we look at the text, it is an empty string. So calling toString on a nullable value type just produces an empty string. There is also a very useful method on all nullable value types called getValue or default. If you call that on a value, on a valid value, then it simply returns you the valid value. You'll notice we can assign this thing to int, right? It never returns null, so we can assign it to int. If the receiver is null, right, which it is in this case, then it produces the default value of an integer. The default value of all numbers is 0. There's also a handy overload of the getValue or default method that takes an argument that tells you what default value you would like. So if for some reason you want a default value of 10 instead of 0, then this will give you 10 in this local variable because x was null. If it had not been null, then you would have gotten its value. There's also a property called value. The value property may only be used if the expression actually, if the receiving expression actually has a value. So you can see here that if we try to run this code, we just hit go here. And then when we hit that statement, we will get an exception that says an invalid operation exception, not a null reference exception. This thing isn't a reference. It's a value. An invalid operation exception occurred because the nullable object must have a value. Right, so only use the value property if you actually know that the thing has a value. How do you know? Well, you can use the hasValue property. It will tell you if the thing has a value or not. All right, so let's comment that out again and start over. All right, you can compare nullable value types to null using the equals equals or not equals operators, the same as you would if they were references. And this is actually just the same as calling hasValue. The C# compiler will actually detect this pattern and turn it into a call to hasValue. And so in this case, it would say not null because this guy is not null. It actually has a value. All right, same thing here. All right. I had said before I wanted to talk about an odd little operator called the null coalescing operator. The null coalescing operator is an operator in C#. It takes 2 operands, as many of the operators do. Its effect is it produces the value of the first operand if the first operand is not null. And it produces it evaluates and produces the second operand if the first operand was null. So the interesting thing about this operator is that it's a little bit like the conditional operator, the ternary operator, in that it doesn't necessarily evaluate all of its operands. It only evaluates its second operand conditionally if the first operand were null. And this is really, really useful when you're dealing with null values. because it's essentially a very compact way to do a get value or default. So if I want to say I want the value 10 if this thing is null, or I want its value if it's non-null, right, then we can just use the question mark operator. So if I step over this thing, then you can see that value has become 10 because x was null. If I give x a non-null value and then do the same thing, then it becomes 123. Right? It takes on the value of x, and the 10 over here is never even evaluated. The null coalescing operator also works with reference types. So if I have a string, first name, let's say Madonna, and a second name, which is null. Madonna actually does have a second name. She just doesn't use it, but let's pretend that she doesn't. Then we can say, well, I want to take the first name and append a space to it, and then append the second name, if there is one, or if it is null, then I want to append the string no last name. Right? And so if we do that, then we'll see that name is Madonna, no last name. If she had had a last name, then we would not have evaluated this. We would have just used the value of second name. So you can use the coalescing operator with either reference types or nullable value types, but they have to be nullable. Now you'll notice I have parentheses around this here. And the reason for that is because this is a very common mistake, and I get questions about this quite frequently. This code is wrong. What do you think this is going to do? Well, let's step into it and find out. Right? Well, this name is now Madonna with a space after it. So something has gone terribly wrong here. And I'm just going to put a breakpoint here and then stop this program. What's going on here is, remember we talked in the previous course about how the C# compiler determines where to insert parentheses on your behalf on the basis of the operator precedence. So in this case, what it's going to do is C# is going to parenthesize this expression like this. It's going to say, first thing I'm going to do is I'm going to I'm going to concatenate these two strings. Next thing I'm going to do is I'm going to concatenate these two strings. And now I'm going to ask the question, is this thing, this whole thing in the parentheses, is that null? And if the answer is no, then I'm going to use it. And if the answer is yes, then I'm going to use this. But this expression here is never going to be null because we have a bunch of string concatenations. And string concatenations can produce an empty string, but it never produces a null string. So this code is meaningless and wrong. But it's very, very easy to write, as you can see. I see this question all the time of I'm trying to use the null coalescing operator in a string concatenation, and I'm getting a bizarre result. So be very, very careful of that. The better thing to do, though, is to simply not use the null coalescing operator here at all, or rather, not use it in a string concatenation. Instead, use a string interpolation. So it would be better to write this code in C#6 to use the string interpolation here, where we have the first name followed by a space, followed by, and then we can put in this brace area the null coalescing operator. And now there is no problem with the relative priority of the addition and concatenation operator, the addition and the coalescing operators, because there is no addition operator. The coalescing operator does not compose well with addition, as we've just seen, but it does compose very nicely with itself. So a common thing that you'll see is this means give me the first name. If the first name is null, give me the second name. If the second name is null, then give me whatever string comes last. Right? So this is a nice way. If you've got a bunch of things, any one of which might be null, and you want to go down them in a list and find the first one that's not null, or this default at the end here, then that's great. We saw in the previous video that if the receiver of a method call is a null reference, then you get a null reference exception. And the receiver is always separated from the call by a dot. And that dot is called the member lookup operator, because it takes a receiver and it figures out which member, which method the name of the call refers to. In C#6, there is a new null propagating member lookup operator that works on nullable value types and nullable reference types. So let me give you just a real quick example of that here. I'm going to uncomment this code here, put a breakpoint here, and run that. All right, so second name is null. We are going to attempt to get its length. And when we do that, we're going to get an exception that says a null reference exception was thrown. So this is wrong. We can fix that in C#6 like this. There is a new question mark dot operator. And oh, I've got a red squiggly. What's going on here? Well, if I mouse over this thing, it says cannot implicitly convert type int question, so nullable of int, to int. An explicit conversion exists. Are you missing a cast? So what's going on here is the meaning of this question mark dot is if the result of this receiver, if the value of this receiver is non-null, then give me the length. If the receiver is null, then give me null. Right? So this is another case where nulls are propagating. And therefore, the result here has to be a nullable integer, because it could take on a null value. So now this code is correct. And if we were to step into this code, then we would see that the length, which is here, becomes null because the second name was null. Had the second name not been null, then we would have fetched its length and written that as a nullable integer into the length variable. Now, if you're not using C#6, then how do you write this code? What people often do is they say, well, I would like a nullable int. It will be the length. And then I'm going to write this ternary operator, this conditional operator. See if the second name is null. If it is not null, then give me second name dot length. If it is null, then give me a nullable integer. And this is, incidentally, the way you get a nullable integer, is you cast null to the type that you want. People often write this, and then they ask me, why is this wrong? Right? If we mouse over that, it says the type of the conditional expression cannot be determined because there is no implicit conversion between null and int. And this error message is a bit confusing. What it's saying is the compiler would like to determine, just by looking at this expression, what is the type of this expression. And it sees, well, on the one hand, I've got null. And on the other hand, I have an integer. And I would like one of those. I would like to find a type that is compatible with both of them. But one of the principles of the design of C# is C# does not invent a new type that it did not see. So the only type that it has to choose from is integer, because the null doesn't have a type. And it says, well, null is not compatible. Now, you might say, well, yeah, but the compiler could know that it's being assigned to a variable of type nullable int, and maybe it could use that as the type. And yes, it could. But you run into more technical, difficult problems where that involve more complex scenarios than this, where the chain of reasoning that you need to go through to figure out what the type of the thing should be can be very long and very complicated and contain loops and contradictions and stuff like that. So the designers of C# wisely said, you know what? We're not going to do any of that. We simply require that the types of both sides be compatible for the ternary operator. So we have to say int question in here. And now the compiler can reason, well, this thing is a nullable int. This thing is an int. The best type between those two, the more general type, is nullable int. And in fact, that nullable int is assignable to this variable, so everything's good. Now, the way people often try to write this code is like this. Right? They'll say, I would like second name.length, and then they'll try to use the null coalescing operator. But you, I'm sure, can immediately see why that's wrong, because I just explained what the null coalescing operator does. The null coalescing operator says, is this thing null? Right? If it is not null, then give me its value. If it is null, then give me this value. Right? But this, if second name is null, the result of this expression is not null. If second name is null, the result of this expression is throw an exception. All right, and also the nullable propagating member access operator can also be used on nullable value types. So if we want to know the day of the week of a nullable date time, then we can say date question mark dot day of week, and then day of week will become either null, as it would here, where date is null, or it would become the day of the week if it were not null. Also, before we finish up here, one fun fact. The C# compiler team refers to this operator as the Elvis operator, because if you squint, it kind of looks like a guy with a weird haircut. Yeah, the C# design team is like that. Summing up, any normal value type can be made nullable by adding a question mark to that type. Most of the operators in C# are lifted to nullable. In a lifted operator, the result is null if and only if one of the operands is null. The member access operator, the dot, is not lifted by default. But if you want to make it lifted, then you use question mark dot, and that only works in C#6. The coalescing operator, which is 2 question marks, gives you the value of a nullable if it has a value, or it gives you the right-hand side of the operator if the left-hand side of the operator happened to be null. But be careful, because this thing has low operator precedence. It does not play nicely with other operators.